Welcome back, everybody. So for our final talk, it's all about performance in React. Performance, admittedly, it's been kind of a lot easier these days than it used to be with like pure components and pure functions kind of being built into the framework, but you still don't get any free passes. And when you do get something wrong, it's like an entire new skill set to learn how to debug that thing and how to find the culprit of your performance problems. So to talk all about that, where your performance problems are coming from, how to debug them, please welcome Clément Pasteau.
Thanks. Can you hear me? Yeah. Cool. So hi, everyone. I'm really happy to be here tonight. So my name is Clément. I've been working at Theodo for more than 2 years now. And basically, I've joined the UK about 1.5 years ago. And since I joined the UK, I've been working mainly on React. So today, I want to share with you a story. Actually, I want to share with you my story since I joined London. So I've been working on multiple projects in React, thanks to Theodo. And I've encountered so many problems in performances that now I want to share them with you. Because I think that once you encounter a problem, like you said, it's so hard to actually debug it. Once the application is getting really big, then it's worth actually trying to get the good practices from the start. So let me share with you some of the examples of the projects I worked on. So the first one, basically, as a customer, we wanted to let them enter their existing finance on existing finance, basically, and then play with some numbers and being able to see how much they could win with a new finance, with a new provider. So the goal was they enter a lot of values on the page, they can play with sliders and everything, and they could see in real time what was the new deal they could get with another provider. And obviously, we didn't do it wrong. We didn't do it right, sorry. So it was really slow. So it was basically unusable, and we had to dig into why is it happening. And that was waste, because we lost time trying to understand what was the issue. Another example, on this page, we had a lot of inputs. The goal was for the user to be able to enter lots of information, and for another user to be able to comment, and basically like a collaborative tool like a Google Drive. But obviously, we are not as good as Google, and we didn't manage to have something really performant, and we had more than 100 inputs on the page, and when someone was trying to input something, then that was really slow, that was hard to use, so it wasn't good to use. So I could go into these two examples together to show you what were the mistakes I did and we did, but I think it's more interesting to actually start from scratch and create together a really small example, and then trying to understand what are the mistakes we can do when we create something really small. So what I did is create the simplest experiment possible, and we're going to go through it together to understand how we can fix the small problems that we don't see from the beginning. So this is my experiment. Basically, this is an application where you can enter 4 inputs. The 2 first one will actually show you the sum just below. The 2 second one will show you the sum below as well. And then the total will do the first sum times the second sum. It's a Redux application, because we are used to use Redux. And we have, on this application, I have basically 2 components, the main components, and then the an input field that I use 4 times on the page. And how do I display the sum and the total with only selectors from the Redux store? So it's fairly easy. You say, I'm not going to do any mistake by creating such a simple app. But actually, we do a lot of mistakes. So let me show you first. When we look on internet, what is the biggest problem we can encounter while we are trying to improve the performance is actually because we are re-rendering our components, even if they don't need to. So the main thing you have to remember from this talk, if you don't know it already, is you need to avoid re-rendering. You need to avoid letting your components re-render if they don't need to. Cool, so let's try to take a look at this simple app together. This is my app. So what I did is, basically the first step, I put some console logs in my render to see what's happening. So let's say, I'm going to clear that quickly. If I refresh the page, then I see that my home page is getting rendered, and my inputs are getting rendered 4 times. Makes sense for the first re-render. But if I start to type, in the first input, what do I see? My home page gets rendered again, which makes sense, but my inputs are getting rendered 4 times. So here we see there is a problem. Either one of my input is getting rendered 4 times, or each input is getting rendered again. So this is the first way you can actually try to understand if you have a problem. There's also a cool tool, which is the Performance tab of Chrome. So if I go in the Performance tab and I say, I want to record what's happening on this page, and I type again my component, I stop, then I can see the whole profile of what happened on this page. So here we can see it took 200 milliseconds, and we can see again that here my input field was updated 4 times. So we see exactly the same problem, and if we go a bit deeper in the tree, we can see that the render function has been called 4 times. So we don't learn a bit more than just putting console logs, but it's a bit clearer visually. And then there's another tool to actually dig deeper into what's happening on this page. If you install the React extension, then usually you use it to dig into what are the components used on your page. But you can also use the highlight updates, which helps you see on the page which components are re-rendering with colors. So if I start typing in my first input, then we can see the colors happening. So we've seen, it gets out briefly, but we've seen that the home page gets rendered, and each input gets rendered as well. So I've got a problem. I did something wrong. So let's try to understand together what did I do wrong in such a simple app. So this is the 3 tools we used, and these are the ones you can use actually to try and dig when your components are re-rendering. So what did I do wrong? If we want to understand what's happening when the components re-render, we have to understand the lifecycle of a component. So when a component mounts, basically when a component appears on a page, then the mounting part is called. Then when a component needs to render again, it will receive new props. It will decide if it needs to render again or not, and then it will render. And when it needs to disappear, then it will unmount. So by default, React will trigger a render of a component if it receives new props. So let's try to understand why my component receives new props. Well, obviously, I'm using Redux, which means that if you're not familiar with Redux, but we've seen it with the previous talks, we've got the view, which is my home page and my inputs. And when I want to type something into my input, an action is triggered to modify the store so that the view receives the new store. So in Redux, every time you do a change, it creates a new store to be able to debug and see in the past what happened. So it means that new props will be passed to my components, which means that it will re-render again. So this is my input field. It's fairly simple. I'm using prop types. And I extend from a basic React components. So my input is fairly simple. It gets a value and an unchained function, the value being the value getting from the Redux store, and the unchained is the action dispatched to get the new value, to set the new value in the store. So how can we make sure that if the value doesn't change and the unchanged doesn't change, the component doesn't re-render? So there's a tool for that. There's a tool for that, which is the pure component. So like you said, it's by default, a pure component will try to say, I'm a component, but if I don't receive any new props, I will not re-render again. So okay, cool. Let's not dig too deep into what a pure component is so far, but let's try to use it and see how it works. So what I do is extend my React with pure component and see what's happening. Well, what's happening is in my console, I can still see that my input field is rendering 4 times. So it's not enough. So let's try to understand what's happening. My component is rendering because it receives new props. So there's something, either the function or the value of my input, that is different than the previous state. So the hard way to understand what is different than the previous state is either you modify your component will update and you put console logs or what was the previous value and the new value. But it's a bit fastidious because in this case, I've got only 2 values in my store. But if I've got start to have, 2 props, but if I start to have a lot of props, then it's going to be really hard to debug all your components and all your props. So actually, there's an easy way to do it. It's using a component called, a tool, called why did you update? Fairly straightforward. So it's so easy to use. You install the package, you say, I want to require it, and then I wrap it around React. And then every time you will play with your application, you will see in your console information about components that render but shouldn't have rendered. So in this case, what do I see? I exactly see what I wanted to see. 3 input fields have rendered, and they shouldn't have to. So in my case, they tell me it received a new function. Maybe it shouldn't have changed, because maybe the function is doing the same thing, but it's different. So I could avoid them. Cool. So how do I ensure that this function doesn't change? Let's take a look at my home page. There's a bit of code there. I've got 4 inputs, and my value comes directly from the store, and my onChange is basically a function that takes the event of the onChange and dispatch the new value to the store to get changed. Cool. So what's wrong with that? Well, what's wrong with that is that if the value changes in the store, then the whole render of the home page will be triggered again. And if it's triggered again, then the functions inside the onChange will be generated again, which means that this first one that takes an event and returns set value of value 1 will actually be a new instance of the previous one. It means that even if it does the same thing, it's a new instance, which means that my component will think that it's a new value. So how could we fix that? Yeah, I already said that. So it means that every time you actually create a function inside your render, then it will be a new instance, so it will be new. So it's not a good practice. There's a way to avoid doing it. There's an ESLint, which is, I forgot the name, let's see afterwards. But basically, how could you do that? Let's say I want to create a function out of the render, but because I've got 4 different inputs, I'm going to put a different key for each. So I create my own change that takes a key and return a new function. Well, it's not going to work either, because every time my render of my home page will be called, the onChange of the key will actually generate a new function, which means the instance will always be different. So it's not going to work. The only way you can make it work by creating the functions there is actually by generating your fork functions before the render, and then directly setting them inside your input field, so that the next time your home page will render, then the onChange will be exactly the same because it's not going to change. But again, it can be a bit fastidious because let's say you have a lot of functions you use on these components. You don't want to define all of them before. So there's another way to do it by keeping the same structure as before, is by using the should component update that we, I think, all know. So what I'm going to say is for my input field, you're going to change only if the value changes. So how do we do that? We say my should component update. We'll take a look at the next props and the current props, and we'll return true, which means re-render, only if only the value is different than the previous value. And I don't care about the onChange because I know I'm not going to change it. In this case, we can see that with the React highlight update, only my component changes, so I win a lot of performances. If we take a look at the performances in the Google Performance tab, the Chrome Performance tab, sorry, we can see that the render is called only once, so we actually win a lot of time. If we have to learn something from this part, is the pure component that actually helps you comparing all your props and re-rendering only if they are different. You should never put any function in your render because it will always be a new instance. It will be badly interpreted. And the should component update will always be here to save you if there's a problem. There's still something wrong. If we take a look at my profile here, we can see that the left part is getting bigger now. So what am I doing in this one? We can see that I'm doing get sum1, get sum2, and get total, which is also divided into get sum1 and get sum2. So basically, this is what's happening when a value changes. It tries to calculate the sum1, and it tries to calculate the sum2 as well, even if the value of the sum2 didn't change. And the total calculates again the sum1 and sum2. So what did I do wrong here? Because I'm losing a lot of performances calculating things twice. So this is my selectors, fairly simple. I've got get value 1, 2, 3, 4 that gets the value from the state. The sum1 sums the 2 value, the sum2 sums the 2 value, and the total does sum1 times sum2. It's fairly simple, but the problem is every time the store changes, the selectors will be called again, which means that all these functions will be called again, and obviously, everything will be calculated again. So how can I fix these two problems? Well, there's only one way to fix this, is to cache the results of your selectors to make sure that these values, if they don't change, you're not going to recalculate the sum. And there's a tool for that, which is called Reselect, which is really cool. It's really easy to use. How do I use it? You install the package, you import the create selector from Reselect, and then you can say, my sum1 will be a selector based on the value 1 and value 2 that will return the sum, same for the sum2. And then the total will get the two other selectors created and return sum1 times sum2. Which means that if I change the value 1 by typing into the input, the sum1 will be recalculated because the value is new, but the sum2 will not be recalculated because the value hasn't changed. And then, because the sum1 will be set in the cache, then the total will not recalculate the two sums and directly multiply them, which means you win a lot of performance. If we take a look at the performance tab, we actually win so much. Before, it was that big, and now it's that small. So it's pretty cool, even on a simple app like that. So what about a bigger app? Well, obviously, if now you know these two things, avoid re-rendering and try to cache all the logic you do in your selectors, then you can fix at least, I think, at least 90% of all the problems of your React apps at the moment. But it's harder to debug, obviously, because your application will be bigger, which means that the message I want to share with you today is you need to start using pure components as much as you can. In my case, I use it all the time because I think that the only case where the pure component is not useful is when your store is mutating, which means that you are not using correctly Redux. And instead of changing the variable you have in the store, you keep the same variable, the same object, and you expect your component to re-render by itself. Take a look at the performance regularly, because what we do now in Theodo on most projects is every time we end a feature, we take a look directly into the highlight updates or in the why did you update to see if we did something wrong. And by doing it right away, it's not something you're going to do afterwards. It's going to take more time to come back to it and then cache your selectors. So if we come back to my examples, in these examples, the problem we had is we are not caching the selectors we had, which means that a lot of things were recalculated. But once we used the selectors, well, the application was really quick. It was really cool. The second one was we had so many inputs on the page, and we were not avoiding the re-rendering. So by using the pure component and the should component updates wisely, we managed to have an application that was performant. So that's it for me. I hope you learned something, and if you, yeah, that's it.
Okay, any questions for Clément?
Hi.
Okay.
There is some discussion around if using pure components all the time or not, since if for a component that you will like it to re-render all the time, like it doesn't really care, or it's very unlikely that it's going to receive the same props twice. The pure component will have another cost of having to calculate with the previous props. So would you say there are situations where we should use the component, or should we just like default to pure component, but maybe switch to just regular old component, or maybe as a functional component where it's appropriate? How would you draw those lines?
It's a really good question. In our case, we try to use it pure component all the time, because we never had the case of having a component that needs to render all the time. Or if it needs to render all the time, then I think it's really specific, which means that, yeah, in this case, then you can switch to an old component or override the should component update to tell him when it should change.
Any more questions? Cool. Clément, thank you very much.